settle in and let your breathing slow, as if the air itself is getting quieter. Tonight, you are not looking at a map, you are sinking into it. One cold ridge, one patient river, one soft coastline at a time. Somewhere high above the ordinary world, K2 waits in the dark, not as a heroic summit, but as a steep, broken pile of rock, held together by ice and bad luck. Congratulations! You made it up here in your imagination, where every step costs a little more than it should. With the Sleepless Geographer nearby, you will drift from thin air to moving wind, from rivers that never stop arguing with stone, to continents that slide so slowly you can almost fall asleep mid-collision. Up here, you think you are standing on something solid, a confident peak, a finished sculpture. Wrong. You are standing on a slow disaster that happens one grain at a time, and it just happens to be shaped like a mountain. The air is thin enough to feel unfinished, like someone forgot to add the final ingredient. Each breath is less a gulp and more a careful sip, the kind you take from a straw that keeps collapsing. Your lungs still do their job, but your body starts negotiating. Your muscles ask for more oxygen, and the mountain just shrugs. That is the first quiet reason you would not survive the summit of K2. Not drama, not heroics, just chemistry and arithmetic. At this height, there are fewer oxygen molecules in each mouthful of air. Your blood can only carry so much, even when it tries its best. So you move slower, you think slower, and little mistakes stop being cute. You look up, and in the dark, the mountain pretends to be a clean, white pyramid. It is the classic postcard lie. In reality, K2 is steep, broken rock, stacked at an angle that feels personal. The ice is not a smooth blanket. It is glue, frozen in place, brittle, and sometimes temporary. Geologists would tell you this mountain is built from ancient crust that got caught in a collision. The Indian plate shoved north into Eurasia? Like two shopping carts meeting in a parking lot. Only this parking lot is the entire planet. The collision did not end. It just slowed down enough for humans to get sentimental about it. That pressure-folded rock lifted it, cracked it, and left it hanging high in the wind. You are not on a peaceful summit. You are on a wound that never quite healed. The cold here is not theatrical. It does not leap out and shout. It is patient, the kind of cold that steals from you while you are busy. It takes heat from fingers first, because fingers are optimistic and stick out. Then it takes toes, because toes are far away and easy to forget. Then, if you stay long enough, it starts taking thoughts. You can feel it in simple decisions. Do you stop to adjust a strap? Or do you keep moving? Do you drink water, even though it is half ice and tastes like metal? Up here, survival is not one grand moment. It is a chain of small choices, and the chain can snap anywhere. And K2, being K2, does not make it easy. The wind arrives without asking. It does not travel to the mountain. It is born here, shaped here, accelerated here. The peak forces air upward, and as air rises, it cools. Cold air cannot hold as much moisture, so water condenses. Cloud builds fast, thickens, and starts throwing snow, not gently, but with an agenda. You have heard the phrase, the mountain makes its own weather. Up here it is not a metaphor, it is a machine, with no off switch. 1 minute, the sky is a dark bowl scattered with stars. The next, your world is white noise. Snow crystals hit your jacket with a dry hiss. Spindrift snakes across the slope, crawling like smoke that forgot it is frozen. And the ground under you? It is not really ground. It is a steep skin of ice over shattered stone. Somewhere below, a glacier is flowing, not fast, not dramatic, but always moving. Ice is a solid that behaves like a very slow liquid. It creeps downhill under its own weight, deforming one crystal at a time. If you could wait here for a few centuries, you would watch the mountain rearrange itself. Ridges would sag. Seracs, those tall blocks of glacier ice, would topple. Avalanche paths would shift like the habits of an old animal. Congratulations, you are standing on something that is quietly trying to leave. Your body does not like the altitude, and it does not like the cold, and it really does not like the combination. Cold makes your blood vessels tighten. That saves heat for your core and abandons the edges. Altitude makes your brain swell slightly because it is irritated by low oxygen. So now you are thinking through a mild fog on terrain that punishes clumsiness. This is how not surviving usually happens. Not as a single cinematic fall, more like a stack of tiny problems, each one manageable, until they arrive together. A glove gets damp, and damp becomes cold. A bootlace freezes stiff, and you cannot feel your fingers well enough to fix it. You stop moving for just a minute, and your body cools. Your judgment slips, and you take a step onto a slope that looks stable. But stability is a rumor up here. K2 is famous for steepness and for routes that funnel everything downward. Snow that falls high does not stay high. Gravity collects it, compacts it, and sends it sliding. Ice fractures along old weaknesses because ice remembers every stress it has ever felt. Below the summit, there are features with names that sound like warnings: bottlenecks, couloirs, hanging seracs, places where the mountain stacks risk in neat little piles. A serac can collapse because the glacier moved a few inches, or because the sun warmed one side more than the other, or because that is what it was always going to do, and tonight was simply its turn. You cannot negotiate with that. You cannot explain that you came a long way. The mountain is not angry. It is indifferent, which is worse, because it never gets tired of being itself. And still, you are here, listening to the wind, feeling the slope under your boots, watching the darkness press against the edge of your headlamp. You can imagine the rock beneath the ice. Not solid blocks, but fractured slabs, squeezed, folded, and broken during the uplift of the Karakoram range. The rock is old, but the mountain is young. Geologically speaking, it is still rising in places, even as erosion gnaws at it. That is another quiet truth. Mountains are built and destroyed at the same time. Tectonics pushes them up, and gravity pulls them down. Snow, ice, and wind act like patient sandpaper. Water, when it shows up, works like a crowbar. Even in the dark, you can sense the shape of the ridge. The crest is sharp enough to make your stomach tighten. On one side, the slope drops away into unseen air. On the other, it drops away into different unseen air. The difference is mostly psychological, but psychology matters when oxygen is scarce. You take a careful step and feel the snow compress. Snow is not one thing. Fresh powder is a chaotic pile of crystals, full of air, easy to shove aside. Old snow turns into fern, a denser, grainy stage in between snow and ice. Given time and pressure, fern becomes glacier ice, harder, bluer, more serious. On K2, these layers can stack in awkward ways. A light layer can sit over a slick crust. A wind slab can form, stiff and cohesive, like a sheet laid over emptiness. It looks supportive until it breaks as a single piece. You would not survive the summit because the mountain is not a staircase. It is a testing ground for your weakest system. If your lungs are weak, it finds your lungs. If your circulation is weak, it finds your fingers. If your decision-making is weak, it finds your timing. And timing is everything. Storms here arrive fast because the mountain interrupts the flow of the atmosphere. Air masses that would have drifted by at lower altitudes are forced up. They cool, condense, and unload. Sometimes you get a brief window, a calm that feels like mercy. Then the wind returns and the sky closes like a door. This is why climbers talk about weather like it is a personality. The jet stream can dip, and suddenly the summit is wrapped in violent wind. The temperature drops, and exposed skin can freeze in minutes. Not because the mountain hates you, but because physics is consistent. You can hear that consistency in the small sounds, the crunch of snow underfoot, the soft clatter of ice crystals skittering across your jacket, the low continuous push of wind against rock, like the mountain is being sanded down in real time. It is easy to think wind is just air moving around. Up here, wind is an erosion tool, a conveyor belt of particles. It picks up snow grains, ice shards, and dust and throws them against the mountain's skin. Over time, this scours ridges, sharpens edges, and polishes exposed rock. You might notice the way surfaces look planed, smoothed, and stripped. On the highest ridges, snow does not collect in gentle blankets. It is peeled away, packed into hollows, stacked into drifts where the wind loses energy. And those drifts, they are not soft pillows. They are architecture. Cornices form where wind carries snow over a ridge and drops it on the lee side. The snow piles out into space, building a lip that looks harmless from above. From below, it is a looming overhang. It can be solid for a while, then fail without warning. So you do what humans always do in dangerous places. You simplify. You narrow the world to a few rules. Step here, not there. Breathe, then move. Do not trust the white edge. Do not stop too long. In the dark, the summit is not a trophy. It is just the highest point in a long system of slopes. The reward is mostly symbolic, and symbols do not keep you warm. That is the sardonic part of K2. It is deadly, not because it is magical. It is deadly because it is a pile of steep geology placed in thin air under a weather machine. And yet, as you stand here in imagination, you can let the mountain do what it always does. It can continue being cold and high and indifferent. You can simply observe without paying the usual price. You can let your mind drift down the ridge, away from the summit, and notice what is shaping this place when nobody is watching. Ice wedges into cracks. When water freezes, it expands. That expansion forces rock apart, slowly Repeatedly, the world's most tedious crowbar. In daytime warmth, a thin film of meltwater can seep into fractures. At night, it freezes, pushes, and widens the gap. Over seasons, the mountain sheds flakes, slabs, and boulders. Gravity does the rest. Rockfall is not rare here. It is a background process, like breathing. Those rocks tumble onto glaciers. The glacier carries them, embedded like dark scars in the ice. As the glacier flows, it grinds rock against rock, producing fine sediment called rock flour. When meltwater streams carry that flour away, the water turns milky, pale blue-gray, like the mountain's bones dissolved into a drink. And while you are thinking about that slow grinding, your attention can move from K2's ridges to the wider world. Because the wind that bites your face here, it does not retire when it leaves the mountain. It goes on to do quieter work elsewhere. It becomes a sculptor with unlimited time. And as the wind keeps polishing the mountain's edges, you start to notice what it's really doing everywhere else on Earth. Quietly grinding whole landscapes down. Wind does not just pass over land like a bored visitor. It rearranges the surface, one grain at a time. If you want to understand it, you have to stop imagining wind as invisible and start imagining what it carries. In cold places, it carries snow. In dry places, it carries sand. In volcanic places, it carries ash, light enough to drift like gray fog. You can picture yourself stepping off the high ice and onto a long ridgeline, lower now, where snowfields stretch and the wind has room to build patterns. The snow is not flat, it is rippled, like a frozen ocean caught mid-wave. Those ripples have a name, sastrugi. Wind carves them into hardened ridges, and they can trip you when you are tired. Snowdrifts are the wind's handwriting. They show you where air slowed down, where it curled, where it dropped its load. A boulder creates a wind shadow, and snow piles neatly behind it. A cliff edge accelerates the flow, and the snow is scraped away, exposing hard ice. It is almost gentle until it is not. Cornices again, built silently, hanging out over space. They look like soft pillows from a distance. Up close, they are a suspended mass, layered and compressed. If you walk too near the edge, you might be walking on air supported by snow. Congratulations, you found a trap that looks like comfort. Wind is picky about sizes. It can lift and carry fine grains easily. It struggles with heavy pebbles. So it sorts the world the way a bored hand sifts through a jar of mixed nuts, tossing the light pieces farther away. In a desert, that sorting becomes obvious. Imagine you have drifted far from the mountain, down into a basin where rain is rare and the sky is a hard blue most days. Here, wind is not cold, it is dry, and it tastes faintly of dust. Sand is not just tiny rocks. It is a specific size range born from the breakdown of larger stone. It can come from river deposits that dried out. It can come from ancient seabeds exposed by retreating water. It can come from mountains that weathered, fractured, and fed sediment down into lowlands. Once sand exists in quantity, wind can turn it into a moving landscape. Dunes are not piles. They are migration. Each grain hops forward in little jumps, lifted by gusts, then dropped, then lifted again. This hopping motion is called saltation, like the sand is skipping across the ground. Over time, Dunes walk, not fast, not in a way you can track in a single night, but if you could return after years, you would find the dune has shifted, inching in the direction of the prevailing wind. Some dunes even sing. In certain deserts, when dry sand slides down the face of a steep dune, it can produce a low hum or booming note. The grains move together in a synchronized sheet. Friction, size, and dryness all matter. The sound can roll across the landscape like a distant engine, as if the desert is clearing its throat in the dark. It is a comforting thought in a strange way. The land has its own music, and it does not require an audience. Wind also polishes rock, especially in places where sand is plentiful. Sandblasting happens naturally. Grains strike exposed stone again and again. Edges soften. Surfaces become smooth, sometimes glossy, sometimes etched. In some places, rocks develop ventifacts, stones carved into flat faces and sharp angles by persistent wind. A rock can end up looking like it was shaped by a tool, but the tool is just time and abrasion, the planet's favorite hobby. And that is the larger point. The world's sharpest places often become round, not by piece, but by endless rubbing. Wind is not strong because it is loud. It is strong because it never truly stops. Even when the air seems still at your height, it is moving higher up. Even when a valley feels sheltered, gusts find their way through. Air flows from high pressure to low pressure, seeking balance, making weather in the process. And when wind has done what it can, when it has scoured and sorted and carried the easy grains away, it leaves behind heavier fragments. A desert pavement can form, a surface of pebbles and stones that protects the finer sand beneath. It looks like a natural gravel road, and it crunches underfoot. Humans see a flat, dry plain and think, finally, stability. But wind is still at work. It is just working on a different schedule than your patience. You might start noticing how wind and mountains collaborate. A mountain range forces air up and over. On the windward side, air rises and cools, and moisture condenses and clouds form. On the leeward side, air descends, warms, and dries out. That is a rain shadow, a simple idea with enormous consequences. One side green, the other side brown. One side forests, the other side open scrub. All because air had to climb, and in climbing it gave away its water. So wind is not just an eroda, it is a planner. It decides where water falls, where snow persists, where soil stays moist enough to grow roots. Still, for all its persistence, wind eventually hands the job over, because a single raindrop, given enough friends and enough time, can do what wind only dreams of. It can pick up a continent and carry it away, grain by grain, to the sea. And when the wind finally hands the job over, water steps in, less dramatic than a storm on a movie poster, and far more persistent. You feel the first raindrop hit stone, and you understand something quietly humiliating about scale. Wind can sand and polish, yes, but water can take. Not in one loud theft, not in a single flood that makes the news. It takes in daily payments, the kind you do not notice until the bill is paid in canyons. You are not standing beside a river yet. You are inside the beginning of one. a thin temporary sheen on rock, a darkening patch that spreads, then gathers itself into a bead. Surface tension holds it together for a moment, like the planet hesitating. Then gravity wins, because gravity always wins eventually. The bead moves. It finds the smallest groove, the faintest weakness. It slides into a crack you would miss with your eyes. And now, congratulations, you are participating in erosion, Earth's longest running job. A river does not start as a river. It starts as confusion, water choosing between options. It starts as sheet flow, a thin film sliding downhill. Then it collects into rills, narrow threads that begin to commit, then gullies, then channels, and eventually something that can carry stones. The trick is that water is stubborn, but it is not strong. A single trickle cannot muscle through bedrock. It wins by repetition, by patience, by showing up every day. It is the slow demolition crew that never asks for overtime pay. You can feel the slope under you as the land tilts. On steeper ground, water moves faster, and faster water carries more, not because it is angry, but because it has energy to spend. Energy turns into motion. Motion turns into work. And the work is moving sediment. The earth relocated. There is a word for the space a river owns: a drainage basin, a catchment, a collection bowl for the sky. Every raindrop that lands within its boundaries becomes part of the same journey. It is a quiet sort of empire, ruled by gravity and shaped by ridgelines. You might think those ridgelines are permanent borders. Wrong again. Divides migrate over time, tugged by stronger rivers stealing from weaker ones. Stream capture is the polite term, like it is a paperwork issue. In human language, it is theft. One river cuts back into a ridge, nibbles over the crest, and steals the headwaters. So even before you reach a canyon, the arguments have started. Water arguing with rock, river arguing with river, slope arguing with time. Now you come to a channel that is finally honest about itself. It is not wide, not yet, but it has a sound, a thin, persistent hiss as water drags sand along the bottom. That sand is not just cargo, it is a tool. Rivers carve in a few simple ways, and none of them are romantic. Hydraulic action, meaning water pushes into cracks and pries them open. Abrasion, meaning sediment scrapes the bed like sandpaper. And solution, meaning some minerals simply dissolve quietly into the flow. You can picture the riverbed as a conveyor belt. Big rocks roll and bump along the bottom during high water. Smaller pebbles bounce, a motion called saltation, the same skipping you saw in dunes. Fine silt stays suspended, turning the water cloudy, carrying entire mountains as mud. And the river sorts it all, because rivers are picky like wind. Fast water can keep heavy particles moving. Slow water drops them like a tired person setting down groceries. This sorting is why gravel bars form on bends, why sand collects in calmer pockets. You walk along the bank and you notice the river is not going straight. It is already wandering, even here. A straight river is usually a river with someone forcing it, or a river with no choice. Left alone, water leans into curves because flow is uneven. On the outside of a bend, water moves faster. It erodes the bank, undercutting it, biting into soil and root. On the inside of a bend, water slows down. It drops sediment, building a point bar, a crescent of sand and gravel. So the bend migrates, not fast enough to frighten you in one night, but fast enough to redraw property lines, to eat farmland, to strand old channels. A river is a sleepy animal, shifting in its bed, and humans build too close, then act surprised when it rolls over. Eventually, the bend can cut itself off. During a flood, water takes the shortcut because water loves efficiency during chaos. The old loop becomes an oxbow lake, a curved leftover, quiet and stagnant. You can see them from above like abandoned sentences. And you begin to understand that a canyon is not a crack. It is not a wound from one event. It is a long conversation that got heated and then got personal. It is water insisting for a very long time that rock should be somewhere else. To feel this properly, you need to stand at the rim of a deep canyon, not for the view, for the sensation of missing ground. The air below you has its own weather. Shadows sit down there like heavy blankets. The walls drop away until your eyes lose interest, and your stomach does not. You think the canyon was made by a great catastrophe. One giant flood, one heroic gouge. Sometimes, yes, floods do the loud work, but most of the carving is ordinary flow. Day after day, year after year. The river does not have to be dramatic to be effective. It just has to be consistent. A river cuts down when it has extra energy and when base level allows it. Base level is a simple idea with a complicated life. It is the lowest point the river can erode toward, usually sea level. If sea level drops or land rises, the river suddenly has work to do. It responds by cutting down, incising, deepening its channel. That is how you get terraces along valley sides, old floodplains left hanging above the modern river like shelves. They are memories of past levels, preserved because the river moved on. And sometimes the river cannot cut down fast enough, or it is forced to flow over a rising landscape. This is how you get antecedent rivers, rivers that keep their course as mountains rise. It sounds noble, like determination. It is really just timing. The river was there first, and it refuses to reroute. You can watch this in places where a river slices through a mountain range, right through ridges that look like they should have blocked it. The river is not stronger than the mountain. It is just older in that particular spot. It kept cutting as the rock rose beneath it, like a saw that never stops moving. The canyon walls tell you what kind of argument you are witnessing. Hard rock forms cliffs. Soft rock forms slopes. Layered sedimentary rock shows stripes. Each band a different environment, a different era. A shallow sea, a river delta, a desert dune field turned to stone. You can run your hand across a sandstone layer and feel old grains under your skin. Those grains were once dunes, once beaches, once river bars. Now they are locked together by cement pressed into rock, and the river is trying to unmake them, grain by grain, patiently reversing history. In limestone country, the story gets stranger. Water mixed with CO2 makes a weak acid, carbonic acid, not enough to burn you, but enough to dissolve calcite over time. So instead of dramatic valleys, you can get karst, sinkholes, caves, disappearing streams. You walk over ground that looks normal until it does not. A depression opens, a hole forms, and the land quietly collapses into emptiness. Congratulations! The landscape is hollow, and it has been dissolving under you for thousands of years. Caves grow like negative rivers, carved not by force, but by chemistry. Water finds a fracture, dissolves it wider, then wider still. Stalactites and stalagmites form later, dripping mineral back into shapes. The cave redecorates itself with the same material it was stolen from. But your river, tonight, stays above ground. It keeps cutting, keeps carrying, keeps going downhill. And because it carries sediment, it also builds. This is the part people forget. Erosion and deposition are the same action, just in different places. A river is a thief upstream, a builder downstream. It robs mountains, then uses the loot to make floodplains. A floodplain looks calm most days. Flat, green, inviting, perfect for farms, perfect for towns. And it is perfect for those things for a reason. Floodplains are fertile because rivers lay down fresh silt, rich in minerals. The same process that destroys homes also grows crops. So humans settle there. Of course they do. Then they act betrayed when the river returns to its job description. Floods feel like exceptions, but they are often the main event. In many climates, the river's real work happens during high flow. Snowmelt, monsoon rains, tropical storms, pulses of water that can move boulders. A river in flood is not a bigger version of a calm river. It is a different creature. It spreads across its floodplain, slows down, and drops sediment everywhere. It reshapes banks, breaks through levees, relocates channels. It can cut a new path in a single night because water loves shortcuts when the rules loosen. Humans respond with walls, levees, embankments, dams, attempts to convince a river to behave. Sometimes it works for a while, but trapping a river behind levees can make floods worse. Water is forced higher, faster, more confined, and if the levee fails, it fails spectacularly. Dams change the story even more. They hold back sediment, starving downstream reaches. A river below a dam can become hungry, scouring its bed and banks. Deltas shrink when sediment no longer arrives. Coasts retreat because the river stopped feeding them. So while you follow the river's course, you also follow human engineering and its side effects. A reservoir looks like a calm lake, but it is a river slowed into silence, dropping everything it carried. Over decades, it fills with sediment because gravity never forgets. Downstream, the river regains itself. It becomes broader, slower, heavier. Tributaries join, each bringing its own sediment, its own chemistry. You can sometimes see the confluence as a seam, two colors meeting, reluctant to mix. The river now has a valley, a true one, a wide floor, gentle slopes, meanders that swing like slow pendulums. This is maturity in river terms, not a compliment, just a stage. And here is another quiet truth. A river is always trying to reach a smooth slope, a profile of least effort. This is called a graded stream. If something disrupts the slope, the river responds. A waterfall can be a disruption, a hard rock layer over a soft one. The soft erodes faster, undercutting the hard until the lip collapses. The waterfall retreats upstream, leaving a gorge behind. It is a moving feature, like a slow zipper opening. Knock a river out of balance and it will fix itself, whether you like it or not. Raise the land and it cuts down. Drop sea level and it incisors. Load it with sediment and it deposits. Starve it of sediment and it erodes more. It is not emotional. It is just seeking equilibrium, like a tired person adjusting a heavy backpack. Eventually, you begin to smell something in the air. Not salt yet, but a damp richness. The valley widens further, and the river divides into multiple channels that braid and rejoin. Braided rivers happen when sediment load is high and banks are easily shifted. They look messy, unfinished, like the river cannot choose one path. In a way, it cannot. Then the ground flattens so much that the river slows down like it is losing interest. This is where it starts to drop the finest particles. Clay, silt, the stuff that stays suspended for a long time. The water becomes calmer, heavier with suspended life. You are approaching the place where the river finally has to negotiate with something stronger than rock. Not stronger in force, but stronger in persistence. The sea. Before you see it, you see its influence. The river begins to fan out, splitting into distributaries. It builds a delta, a broad, low triangle of sediment. This is the river unpacking after a long trip. It drops what it carried, layer after layer, because the current slows as it meets still water. A delta is land that used to be somewhere else. It is borrowed mountain, reassembled at the edge of an ocean. And it is fragile because it is low and young and made of loose material. It subsides under its own weight, slowly compacting. It can also sink if groundwater is pumped out, because humans always find ways to help gravity. Meanwhile, the sea pushes back with tides and waves. In some places, strong tides prevent a delta from forming. In others, waves redistribute the sediment along the coast, smoothing the delta's shape. So, the delta is a compromise between river delivery and ocean rearrangement. People love deltas because they are flat and fertile and easy to travel. Naturally, they build cities there. And naturally, deltas flood, storm surge, river flood, sea level rise. Take your pick. The land is barely above the water that surrounds it, and it is made of the same material the river can move. So, you stand at the mouth, where fresh water meets salt. The river's journey ends, but the sediment's journey continues. Fine particles drift into coastal currents. Sand is shoved along shore by waves. Everything keeps moving, just under a new manager. And once you have followed a river down to the sea, you realize the coastline is not a finish line. It is another battlefield, just with waves. You step onto a beach and the first thing you notice is that it is loud in a steady way. The hiss and collapse of water, the soft grinding of grains pulled back and pushed forward. A beach looks relaxed because it is familiar, but it is built from constant violence, performed in small motions. Each wave is a delivery and a theft. Swash runs up the shore, carrying sand. backwash returns, pulling sand back down. If the waves hit at an angle, the sand moves sideways in a zigzag, a process called longshore drift. The beach is a conveyor belt made of glittering rock fragments. The sand itself tells you its history. Sharp grains suggest youth, recent breakage. Rounded grains suggest long travel, endless tumbling. Some beaches are black, made of basalt fragments from volcanic rock. Some are pink from crushed shells and coral. Some are white, nearly pure quartz, stubbornly resistant to weathering. And then there are beaches that are not sand at all. Pebble beaches, cobble beaches, where the waves have enough energy to carry heavy pieces. Walking on them feels like walking on loose teeth. Each step shifts the stones, and the sound is a dry clatter. Behind you, you might see dunes, because beaches and wind collaborate. Dry sand is picked up and blown inland. Dune grasses trap it, building ridges that can protect the land, until a storm cuts through. Ahead of you, the sea is never truly still. Even on calm nights, there is a slow lift and fall. The tide is working, quietly, predictably, not because the ocean has moods, but because the moon keeps pulling. Tides are gravity made visible. The ocean bulges slightly toward the moon and slightly away from it. As the earth rotates, coastlines pass through these bulges, and water rises and falls. Twice a day, forever, unless the laws of physics get tired. In narrow bays, tides can be dramatic, rushing like rivers. In wide open coasts, the change may feel subtle, but it matters. It exposes intertidal zones, the strip of land that lives part-time underwater. Life here is tough, adapted to drying, soaking, pounding waves, and sudden cold. You walk along a rocky shore and see tide pools left behind, small worlds, temporary aquariums. When the tide drops, they hold water like bowls, crabs, anemones, algae, all waiting for the ocean to come back. But the coastline is not just life, it is geology in retreat. Cliffs are coastlines that have not negotiated. They are rock meeting wave energy head on. The waves attack at the base, exploiting cracks, forcing air into holes. That compressed air expands, prying rock apart. A small explosion repeated endlessly. Over time, a notch forms at the cliff base. The cliff becomes undercut, overhangs, then collapses. The collapse is sudden, loud, satisfying in the way disasters can be. But the real work was quiet, done by thousands of waves before anyone watched. So a coastline can seem stable for years, then change in one afternoon. A calm day, a loud collapse, and the map is slightly different. People living above sea cliffs learn this, sometimes too late. They wake up to new cracks in their yard and the ocean below, patiently collecting. As cliffs retreat, they can leave wave-cut platforms, flat rocky shelves exposed at low tide. Slick with algae, they are the old footprint of the cliff, planed down by wave abrasion. Sometimes, erosion leaves isolated stacks offshore. A headland is eaten back until a pillar remains, standing alone. It looks heroic, solitary, photogenic. It is actually a leftover, waiting to fall. And if you keep following the shore, you notice it is rarely straight. Headlands and bays alternate because rock is uneven. Hard rock resists, forming headlands. Soft rock yields, forming bays. Wave energy focuses on headlands, disperses into bays. The coastline organizes itself into a pattern, like a tired person smoothing a wrinkled sheet. Beaches tend to form in bays, where energy is lower and sediment can settle. Headlands act like natural growings, trapping sand. Humans build artificial versions because they like controlling where sand goes. Growings, breakwaters, seawalls, coastal furniture. This is where sardonic realism arrives, right on schedule. Seawalls protect one stretch of coast by reflecting wave energy, but reflected energy scours sand away, deepening water at the base. The beach narrows, disappears, and the wall is left standing in deeper water, exposed. Protection becomes a new problem. Groins trap sand on one side, starving the other side. So one neighborhood gets a wider beach and the downdrift neighborhood gets erosion. Someone always pays. The ocean is excellent at sending invoices. And then there are barrier islands, long, thin strips of sand parallel to the mainland. They look like vacation. They are actually moving. Barrier islands form from sandbars and coastal sediment, shaped by waves and currents. They migrate over time, rolling landward in storms. Waves wash over them, carrying sand from the ocean side to the lagoon side. This is called overwash, and it is how barrier islands survive rising seas. They do not hold position. They relocate. Humans build houses on them anyway, because humans enjoy pretending. They build dunes, plant grasses, pump sand onto the beach in nourishment projects. Sometimes it works for a while. Then a hurricane arrives, and the island performs its ancient habit of rearrangement. You can stand on a barrier island and feel how temporary it is. The sand under your feet shifts with each step. The wind combs the dunes. The ocean on one side and the bay on the other, both impatient. Even the smell here is a kind of slow corrosion. Salt air feels gentle in your chest and cruel on everything made of metal. Salt crystals form, attract moisture, accelerate rust. Cars decay faster. Railings pit and flake. The ocean is not content with shaping stone. It also eats your hardware. And while all this seems like surface drama, the deeper truth is quieter. Sea level itself is not fixed. It rises and falls over deep time, depending on ice volume and ocean temperature. When glaciers grow, sea level drops, exposing continental shelves. When ice melts, sea level rises, flooding coasts, drowning valleys into fjords and estuaries. An estuary is where the sea moves into a river valley. Brackish water, tidal influence, mudflats, reeds. These places are nurseries for fish, filters for nutrients, buffers for storms. And humans love to dredge them, build ports, straighten channels, because humans enjoy shipping more than mud. If you look at a coastline long enough, you stop seeing it as an edge. It is a zone of exchange, a shifting seam. Sediment arrives, sediment leaves. Storms carve, calm weather rebuilds. The shape you see today is a temporary arrangement. And as the ocean keeps sanding the edges of continents, the deeper truth is that the continents themselves are moving too, just at a speed you can sleep through. You step back from the shoreline in your mind, higher now, as if the camera is lifting. The beach becomes a pale ribbon. The cliffs become a jagged line. The river mouth becomes a stain of brown water spreading into blue. And then you notice something uncomfortable. The entire landmass is not as still as it looks. You think you live on a stable platform. Wrong. You live on a set of enormous slabs, drifting over a hot interior like rafts. These slabs are tectonic plates. They include continents and ocean floor together, because the planet does not care about your categories. They move a few inches a year, give or take, about the speed your fingernails grow, which is an insult really, considering what they can do with that motion. They move because the mantle beneath them convects. Hot rock rises slowly, spreads, cools, sinks. Not a fast boil, more like thick stew that takes millions of years to stir. The plates ride on top, pulled and pushed by forces you cannot feel directly. At mid-ocean ridges, plates separate. Magma rises, cools, becomes new ocean crust. The ridge is a seam where the earth keeps making skin. You would not notice it from the surface unless you were floating above, because most of it is underwater, hidden. New crust is warm and buoyant, so it sits higher. As it moves away from the ridge, it cools, thickens, and sinks slightly. This is why the ocean floor gets deeper away from ridges, a slow sagging of aging rock. At the other end of the journey, old ocean crust meets a continent or another plate. And here the planet gets impatient. Subduction zones are where one plate dives beneath another. Ocean crust is denser, so it sinks. It bends downward into the mantle, dragging water-rich minerals with it. This creates melting, magma, volcanoes, and earthquakes. If you want a line of volcanoes, look for a subduction zone. If you want deep ocean trenches, look for the same. The Mariana Trench is one example, a place where the ocean floor folds down into darkness, deep enough that the pressure would crush you politely and completely. Earthquakes happen when plates lock, then slip. The edges are rough, and friction holds them like clenched teeth. Stress builds over years, decades, centuries. Then the fault ruptures, and the stored energy releases in seconds. The shaking is not the Earth being angry, it is the Earth finally letting go. Most of that motion is invisible day to day. Cities stand, roads stay where they are, so you forget. But every so often, the planet reminds you that the crust is not a floor, it is a lid. There are different kinds of plate boundaries, and each has its own personality. Divergent boundaries pull apart, making new crust. Convergent boundaries collide, making mountains and trenches. Transform boundaries slide past each other like two stubborn strangers in a narrow hallway. Transform faults can be deceptively simple. No dramatic mountains forming, no trench swallowing the sea. Just sideways motion, accumulated until it releases. The San Andreas Fault is famous for this, but transform faults lace the ocean floor too, offsetting ridges like broken stitches. And mountains are not decorations, they are wrinkles. When continents collide, neither wants to subduct easily. Continental crust is too buoyant, too thick, like trying to push a cork underwater. So instead, the crust crumples, thickens, and rises. This is how you get giants like the Himalayas, still rising because the collision is still happening. The Karakoram, where K2 lives, is part of that broader story. a high, tortured region where plates have been squeezing the crust into altitude. Uplift builds relief, and then erosion attacks it, feeding rivers, feeding deltas, feeding coasts. That loop is the planet's quiet rhythm. Build up, tear down, lift, grind, carry, deposit. It is not linear progress. It is cycling, like breathing, only slower. Some mountain ranges are young, sharp, dramatic. Others are old, worn down to rounded hills. The Appalachians, for example, were once as tall as younger ranges. Now they are softened by time, their peaks lowered by hundreds of millions of years of weathering. So, a mountain's shape is not just about how it was made, it is also about how long it has been exposed to the sky's tools. Rain, frost, rivers, glaciers, all those patient hands. And while you think of mountains as stable monuments, many are still adjusting. Isostatic rebound is one of those terms that sounds like a yoga pose. It is the crust rising after being relieved of weight. When a massive ice sheet sits on land, it presses the crust down. When the ice melts, the land slowly rebounds upward. In places like Scandinavia and parts of Canada, the ground is still rising from the last ice age. Shorelines change, harbors shift, old beaches sit stranded inland. So even after the ice is gone, the earth keeps moving, still correcting its posture. You might wonder how we know plates move at all, if the motion is so slow. Because the rocks tell on themselves, magnetic stripes on the ocean floor record reversals of Earth's magnetic field. As new crust forms at ridges, it locks in the magnetic direction at that time. Because the field flips occasionally, the seafloor ends up with symmetrical polis of magnetism on either side of the ridge, a barcode written in basalt. And we can measure motion directly now with GPS, stations bolted to bedrock drift relative to each other, year by year. The numbers are small, but they add up, and they confirm what geology has been whispering all along. But for you, tonight, the important part is simpler. You are lying still, and beneath you, the planet is not. The ground is a slow conveyor. The continents are passengers on moving plates. The oceans open and close over deep time, like a chest inhaling and exhaling. And where plates meet with a little more heat and impatience, the planet opens vents, places where the ground remembers it is still connected to fire. You step closer to one of those vents in your mind, and the ground changes personality under your feet. It goes from quiet stone to something warmer, thinner, more impatient. You think you are looking at a mountain again, a neat cone, a simple story. Wrong. You are looking at plumbing, a heat leak, a crack in the crust that refuses to stay sealed. The air here smells faintly sharp, like struck matches and wet rock. Sulfur, mostly, seeping out in small, embarrassed breaths. The sound is not a roar yet. It is a low simmer, like a kettle that never quite boils. Heat comes up through the ground in patches, and you learn quickly not to kneel anywhere blindly. Volcanoes are not always dramatic, not always fountains and fire. A volcano can be a long, quiet sentence spoken over centuries. It can be a place where the planet simply admits, in a calm voice, that the inside is still hot. You stand on a slope made of old lava flows, stacked like dark pages. Each flow was once liquid rock. Now it is stiff and cracked, and it holds the shape of the moment it cooled. Ropey textures like frozen taffy, jagged slabs like broken pavement. The landscape looks newly built and also already ruined. Magma is the word for melted rock underground. Lava is what you call it after it escapes. That is the entire difference. Location. Like calling the same person a commuter or a traveler depending on which side of a door they are on. Down below, the magma is not a single lake of fire. It is usually a body of melt mixed with crystals and gas. The rock is not fully liquid, not fully solid. It is a crowded slush, and it moves when pressure tells it to. Where does that melt come from? Sometimes it comes from decompression melting. That is when hot mantle rises, pressure drops, and the rock starts to melt. It is less like lighting a stove, more like opening a bottle and letting it fizz. Other times, melt comes from water being dragged into the mantle at subduction zones. Old ocean crust dives down, carrying minerals and seawater locked in its pores. As it heats up, water lowers the melting point of the surrounding rock. In human terms, it makes the mantle easier to melt, like adding a little soap to break surface tension. So the volcano above you is not random. It is a symptom of plate boundaries, a bright red underline in the Earth's long, slow argument. You might picture lava as a fast, glowing river. Sometimes it is, but often it is slower than you want it to be, thick enough to move like heavy stew. Basaltic lava, low in silica, flows more easily. It can run in long sheets and build gentle shield volcanoes, the kind you see in Hawaii, broad and patient, like they are not trying to impress anyone. Silica-rich magma is stickier. It traps gas more easily, and that changes everything. Gas is the difference between a gentle overflow and an explosion. When gas escapes calmly, you get flowing lava and harmless steam. When gas cannot escape, pressure builds, and the volcano becomes energetic. That is the technical term for a mountain that throws itself apart. The gas is mostly water vapor, with carbon dioxide and sulfur compounds. It is the same basic idea as shaking a bottle of soda and refusing to open it. The pressure keeps building, and the release is never polite. You can imagine standing near a crater rim at night, watching the glow from below. The red is not the color of flame. It is the color of rock that is still hot enough to hurt you at a distance. The heat rises in waves that distort the air. Even the stars above look like they are shimmering from discomfort. Congratulations! You found a place where the ground is pretending to be solid. Some volcanoes do not even bother with a cone. In Iceland, for example, eruptions can happen along fissures. Cracks open, and lava pours out like the crust split a seam. You do not get one mountain. You get a line of fire cutting across a plain, writing new land in real time. That new rock starts life sharp and raw. Fresh basalt can be glassy, black, almost blue in the right light. It breaks into edges that slice shoes, tires, skin, patience. Plants do not rush in to decorate it. So for a while, the landscape looks unfinished, like the earth forgot to add the soft parts. And then water shows up, because water always shows up eventually. Rain collects in cracks, frost pries. Chemical weathering begins quietly. Lichens arrive first, the little opportunists eating rocks slowly and calling it a home. So even lava, even brand new ground, begins to decay the moment it forms. The planet builds, then immediately starts unbuilding. It is efficient that way. Sometimes lava cools in a way that looks unnervingly organized. Columnar basalt forms when thick flows cool and contract. The rock fractures into polygon columns, often hexagons, like the Earth tried geometry for once. It looks like architecture, and it is, just not made for you. And beneath some lava fields, you can get lava tubes. The surface of a flow cools into a crust, while the inside stays molten and keeps moving. When the eruption ends, the tube can drain, leaving a hollow tunnel behind. A cave made of lava, smooth in places, sharp in others. A dark hallway where the walls remember heat. Volcanoes also produce ash, which is rock shredded into tiny particles. Ash is not soft like fireplace soot. It is abrasive, gritty, glassy. It can irritate lungs, scratch eyes, and grind machinery into early retirement. When ash falls, the world goes quiet in a strange way. Sound dampens like snow, but the color is wrong. Daylight turns gray, then dull orange, then dim. Streetlights come on at noon, not because it is romantic, but because visibility is a practical problem. Ash can drift for days because the particles are so fine. High-altitude winds carry it across countries and oceans. Airplanes avoid it for a reason. Jet engines do not appreciate inhaling powdered rock. On the ground, ash can become a different hazard. If it gets wet, it turns heavy and sticky. It collapses roofs, clogs drains, turns roads into paste. People shovel it like snow, and it does not melt. It just waits. You start to see how volcanoes can change more than the skyline. They can change soil too. Volcanic ash, broken down over time, can make incredibly fertile ground. That is the cruel trade. Volcanoes can ruin a place and then make it agriculturally irresistible. Humans notice this, of course, so they build on volcanic slopes, plant vineyards in volcanic soils, raise towns in the shadow of craters. They tell themselves the volcano is dormant, which is a comforting word that mostly means it has not erupted recently. The good news is that some volcanoes rest for centuries. The bad news is that centuries are not a long time for a volcano. It is just enough time for people to forget. If you want to feel the planet's heat without the fireworks, you follow the quieter leaks. Hot springs, fumaroles, geysers. These are volcanoes speaking in a calmer voice, letting energy out in controlled size. You stand near a hot spring pool, and the air is thick with steam. The water is an impossible color, turquoise, milky blue, sometimes rust red. The colors come from minerals and from heat-loving microbes. Life that treats boiling water the way you treat a warm bath. The ground around the spring is delicate. Thin crusts, mineral deposits, fragile edges. Step in the wrong place and the surface can break. Underneath is scalding water and mud, waiting like a trapdoor. In places like Yellowstone, geysers are the dramatic version of this system. Water seeps underground, heats up, becomes pressurized, and then erupts as steam and spray. A natural pressure cooker with a timer you cannot predict precisely. A geyser's plumbing matters. It needs narrow passages to trap pressure. It needs a heat source. It needs a steady supply of water. Remove any one of these, and the geyser becomes just a hot spring. Still beautiful, still dangerous, just less theatrical. And then there are mud pots, where acidic water breaks rock down into clay. The mud bubbles and bloops, thick and slow. It looks like the earth is cooking something unpleasant, which, in a sense, it is. It is cooking its own crust into new forms. Not all volcanoes are born at plate boundaries. Some are hot spots, plumes of heat rising from deep in the mantle. The plate moves over the plume, and a chain of volcanoes forms, like a conveyor belt, passing over a blowtorch. Hawaii is the classic example. The Big Island is currently over the hot spot. Still active, older islands trail away, eroded, sinking, slowly turning into reefs, and then seamounts. The volcano builds, then the ocean takes it apart, and eventually the whole thing slips beneath the waves. A volcanic island is temporary land. It rises, it cools, it erodes, it sinks. Sometimes coral grows around it, building a ring. When the island disappears, the ring remains as an atoll, a necklace of reef around a lagoon. So even paradise is just geology on a schedule, and volcanoes quietly influence climate too, not in a poetic way, in a particulate way. Big eruptions can inject sulfur dioxide into the stratosphere. It turns into aerosols that reflect sunlight. The planet cools slightly for a year or two, sometimes longer. You can have summer that feels muted, sunlight that looks pale, not because the sun changed, but because a volcano gave the atmosphere a thin shade cloth. There is a strange comfort in that. The earth has knobs and dials you do not control. The sky can be altered by a mountain, and you will continue scheduling meetings as if none of this matters. You look back at the volcanic landscape and you realize it is not only destructive, it is creative in a harsh way. It makes land, it makes soil, it makes new coastlines. It also makes disasters that do not care about your plans. And after fire reshapes the land, the atmosphere takes its turn, cooling, drying, soaking, and deciding what kind of world can exist on top of the new rock. You drift upward into the air itself, into the part of the planet that actually touches your skin. The atmosphere is thin compared to the Earth's size, a fragile film. If the planet were an apple, the air would be the sheen you polish on the peel. And yet, that thin film does most of the daily work of discomfort. It decides whether you sweat or shiver. It decides whether forests grow or grasslands spread. It decides, quietly, how civilizations arrange their hopes. You find yourself standing on the windward side of a mountain range again. The air here is heavy with moisture. It tastes green even before you see the trees. Clouds stack up against the slopes like they are trying to climb. Moist air rises when it is forced over mountains. As it rises, it cools. Cool air holds less water vapor, so the vapor condenses. Cloud droplets form. Then rain begins not as an event, but as a steady decision. This is orographic precipitation, a technical phrase that means mountains squeeze water out of air. Like wringing a sponge, slowly across a whole range. You walk through a forest that exists because of this squeezing. Everything drips, leaves shine, Moss covers logs like soft insulation. The ground is dark and springy, layered with needles and decay. On the other side of the range, you cross a ridge, and the world changes abruptly. The air feels lighter, drier. The sky opens up, shadows sharpen. You step into the rain shadow, where the mountains have already taken what the wind carried. The same wind, the same weather system, two entirely different landscapes. Green on one side, brown on the other. This is how you can have deserts near oceans, which feels like a joke until you understand the plumbing. Take the Andes, for example. Moist air from the Atlantic crosses the Amazon, loaded with water. It hits the Andes and rises. Rain falls, forests thrive. By the time the air descends on the western side, it is drier and warmer. The Atacama Desert sits there, one of the driest places on Earth, within sight of the Pacific. Or consider coastal deserts shaped by cold currents. Cold water chills the air above it, limiting evaporation. You get fog instead of rain, a gray coast with a dry interior, because the ocean is cold and stingy. So, storms have patterns. They follow temperature gradients, pressure differences, the spin of the Earth. The Coriolis effect, another technical term that means the planet's rotation bends moving air. It makes winds curve, makes storms spin, makes weather feel like choreography. But inside a storm, it never feels like choreography. It feels personal. You stand under a sky that thickens in layers, slate on charcoal. Wind picks up, not all at once, but in pulses. The first gust is a warning. The second gust is an insult. Then the rain arrives, angled, needling your jacket, finding every gap. Rain has texture. Warm rain feels soft, almost forgiving. Cold rain feels sharp, like it is trying to wake you up. In strong wind, rain becomes sideways, and the ground turns slick faster than you expect. A storm can be a low-pressure system drawing air inward. Air spirals toward the center, rises, cools, condenses. Clouds build vertically, swelling like bruises. Thunder happens when charge separates in the cloud, and lightning equalizes it in a violent line. Thunder is the air tearing itself. Lightning heats air so fast, it expands explosively. The sound rolls afterward, because sound is slow compared to light. You count the seconds without meaning to, still pretending you can measure danger. In the tropics, storms can organize into cyclones. Warm ocean water feeds them heat and moisture. They spin, tighten, form an eye, and begin traveling like a machine with appetite. A hurricane, a typhoon, a cyclone, different regional names, same basic creature. It is a heat engine, converting warm water into wind. And the worst part is, often not the wind, it is the water. Storm surge lifts sea level, pushes ocean onto land. Waves ride on top of that surge, hammering structures that were never designed for wave impact. Inland, rain bands dump water for hours, sometimes days. Rivers rise. Drainage systems fail politely, then completely. And afterward, when the clouds finally leave, the landscape is rearranged. Sand moved, trees down, shorelines cut back. A reminder that weather is not just a mood, it is a sculptor. Fog is weather's softer trick. You walk into fog and the world shrinks. Distance becomes uncertain. Sound changes, muffled, directionless. It is a cloud that got tired and sat down, deciding to become a ground-level problem. Fog forms when air cools to its dew point, when it cannot hold its moisture. It can happen overnight in valleys as the ground radiates heat away. It can happen along coasts where warm air moves over cold water. It can happen after rain when evaporation feeds the air close to the ground. In fog, you stop trusting your eyes. Trees appear as ghosts, then become solid as you approach. Roads vanish into white. The horizon is not a line anymore. It is a concept. And then there is cold, the kind that keeps records. You step north or south, depending on which edge of the map you prefer. The light changes first. Sunlight skims low, pale and sideways. Shadows stretch longer than they should. The air feels clean in a way that is almost sterile. Polar cold is not just a temperature. It is a preservation method. Snow falls and does not melt. It compacts, turns to fern, then ice. Layer on layer, year after year, the ice sheet grows. Each layer traps a little bit of the atmosphere, tiny bubbles of ancient air, sealed like a time capsule. Ice cores drilled from Greenland and Antarctica. Let scientists read those layers. They measure isotopes, dust, trapped gas. They reconstruct temperature shifts, volcanic eruptions, greenhouse gas levels. The ice becomes a diary, written slowly and locked away. And the cold preserves more than air. It preserves landscapes. In permafrost regions, the ground stays frozen for years at a time, not just the surface, but meters down, so water cannot drain normally. In summer, only a thin, active layer thaws, and it turns to mud on top of frozen ground. This creates strange terrain, patterned ground where freeze and thaw sort stones into circles and stripes. Ice wedges, where water freezes and cracks, expands, repeats, and eventually forms polygon networks, visible from above. The Earth quietly tiling itself. When permafrost warms, it thaws unevenly. The ground subsides, slumps, collapses into thermokarst. Ponds form, hills sag, roads buckle. Buildings tilt because their foundations were designed for frozen certainty. Climate has a long memory, and it shapes culture quietly. Where people build, what they grow, how they travel. In monsoon regions, architecture expects heavy rain. In dry steppe, herding makes sense, and farming is a gamble. In cold north, storage matters, insulation matters, even language and folklore can carry climate inside them. Storm names, wind names, warnings, embedded in stories. People learn patterns and teach them because survival is often just remembering what the sky tends to do. But the sky is changing too, because the atmosphere is not a museum. Ocean temperatures shift, jet streams wobble, storm tracks migrate, and that means the old patterns become slightly unreliable. Not instantly, not everywhere, but enough to make planning feel like guessing. Still, tonight, you let the weather be what it is. A moving system, guided by physics, full of local surprises. You watch clouds climb mountains and lose themselves into rain. You watch dry air descend and sharpen the light, And when the air dries out completely, the land becomes simpler, fewer sounds, fewer smells, until you are left with the pure, patient emptiness of desert. You step into a place where water rarely stays long enough to matter. The first sensation is openness, not just visual, but acoustic. Sound carries far because there is less vegetation to catch it. Your footsteps feel louder than they should. Desert is not a synonym for hot. Desert is a statement about moisture. It means precipitation is low and evaporation often wins. You can have cold deserts too, places where water is locked up as ice, unavailable to plants. In a hot desert, the sun feels heavy, not bright, heavy. It presses down on your shoulders, warms your skin through fabric, and turns shade into a valuable currency. During the day, the ground heats quickly. At night, the heat escapes just as quickly because dry air holds less warmth. So the temperature drops and the desert reveals its other side. Cold, clear, quiet, with stars that look too close. Distance here is misleading. The air is often so clear that hills look nearby. You walk toward them for hours, and they do not grow much larger. You learn that your eyes have been spoiled by humid places where haze helps you judge scale. The ground under you might be sand, but it might not. Many deserts are rocky. Gravel plains, bare bedrock, crusted surfaces. Sand seas exist, the famous dunes, but they are not the whole story. You walk across a surface of small stones, desert pavement. It crunches like dry cereal. The pebbles sit on top because wind has removed the finer particles, or because repeated wetting and drying lifted stones upward over time. It looks stable, like a ready-made road, but the stability is a thin layer over softer sediment. Then you reach a dry channel, a wash, a wadi. It is empty now, cracked with driftwood caught in thorn bushes. The driftwood is the clue. This channel is not always dry. It is just dry most of the time. In deserts, rain can be rare but intense. Hard ground sheds water quickly, and a sudden storm upstream can send a flash flood racing down a channel, a wall of muddy water carrying branches, rocks, and anything else that was in the way. If you camp in a dry wash because it seems sheltered, congratulations, you chose the riverbed that only exists during disasters. Deserts also love salt. You step onto a flat white plain that looks like snow under moonlight, but it crunches differently. It has a brittle crust that breaks under your weight, revealing dampness below. This is a salt flat, a playa, the floor of an ancient lake. Lakes can vanish when climate shifts, or when rivers change course. Water evaporates, but dissolved minerals remain. Over time, they concentrate and crystallize. Salt, gypsum, borax, the pantry of dried water. In places like the Salar de Uyuni in Bolivia, the salt flat becomes a mirror after rain. A thin sheet of water reflects the sky perfectly. Horizon disappears. You feel like you are walking through clouds, except the ground is salt and will ruin your shoes. The salt flat is not just pretty, it is also a record of vanished climates. It tells you this place once held water long enough to be a lake. Now it holds memory instead. Deserts often sit on plateaus, high, broad tables of land where the horizon feels too far away. A plateau can make you feel small in a different way than a mountain. Mountains intimidate with height. Plateaus intimidate with extent. You stand on one and realize there is no obvious direction to go. Everything is level. Everything is far. The sky becomes the main feature, and the land becomes an endless floor. Some plateaus are built by uplift, crust pushed up without folding too dramatically. Others are built by lava flows, stacked over time into thick basalt layers. Some are carved into shape by rivers that cut canyons down through the uplifted rock. The Colorado Plateau is famous for this. Highland, relatively stable, uplifted over time. Rivers like the Colorado cut deep canyons, exposing layer cakes of ancient sediments. A plateau, then a wound in it, then another wound branching off. In deserts, wind still does its patient work. It lifts dust, carries it far, drops it elsewhere. Dust can fertilize oceans, feed rainforests, influence cloud formation. A desert is not isolated. It exports itself in fine powder. And there are deserts that hum, as you heard earlier, dunes that sing when they slide. The sound is low, resonant, like distant thunder trapped inside sand. It is unsettling and also soothing in a strange way. Proof that even emptiness has mechanics. People live in deserts, of course. They cluster near water because water is everything. Oases form where groundwater reaches the surface, sometimes fed by distant mountains. Aquifers act like underground savings accounts, water stored over thousands of years. Humans pump that water, irrigate fields, grow crops in places that would otherwise grow only stubborn shrubs. For a while, it looks like triumph. Then the aquifer drops. Wells deepen. Water becomes saltier. The savings account runs out, and the desert resumes its old ownership. Deserts also produce mirages, little optical lies. Hot air near the ground bends light. The sky reflects as if it were water. You see a shimmering lake that retreats as you approach, because it was never there. The desert, casually reminding you not to trust your senses too much. And after a while in that dry openness, you start craving green again, not as decoration, but as proof that water can linger. So, you follow the moisture back to where life crowds in, tightly, noisy and determined. You enter a forest, and the world softens. Footsteps become muffled. Light filters through leaves, breaking into slow-moving patterns. The air feels cooler, not only from shade, but from transpiration, water released by leaves into the air. Forests make their own calm. Wind is less aggressive here, broken by trunks and branches. Smells are layered. Resin, damp soil, fungus, decaying wood, the scent of carbon cycling quietly, endlessly. You walk past trees that look solid and permanent, and you remember the planet does not do permanent. Roots pry apart rock, seeking cracks, forcing them wider. This is biological weathering, a gentle strength. A root is soft, but it grows slowly, and slow pressure wins. Fallen logs lie on the ground, and they are not waste. They are habitat, sponge, nursery. Insects chew, fungi digest, bacteria finish the job. Wood becomes soil. Soil becomes food. The forest eats its own past. Soil is not just dirt. It is a living layer where rock becomes biology. mineral particles mixed with organic matter, water, air, and a busy community of organisms. Worms, mites, microbes, countless small lives turning dead material into structure. Soil forms slowly. A thin layer can take centuries to develop, and it can be lost quickly if vegetation is stripped away. Erosion accelerates, and the land becomes poorer, lighter, easier to blow and wash away. That is one of the quiet tragedies of deforestation. It is not just losing trees, it is losing the skin that took a long time to grow. You might find wetlands at the forest's edge where water collects and refuses to leave. A wetland is not quite land, not quite lake. It is a sponge and a filter, holding water in place and smoothing out floods. Marshes are grassy wetlands, open and bright, full of reeds and birds. Swamps are forested wetlands, darker, with trunks rising out of water. Bogs are acidic, often fed by rain, with peat accumulating because decay is slow in low-oxygen water. Peat is stored carbon, partially decomposed plant matter. In cool, wet conditions, it builds up over thousands of years. Humans can drain bogs, cut peat, burn it for fuel, which is, in a way, earning a slow-grown archive of old plants. Wetlands buffer storms and floods by giving water somewhere to spread out. They trap sediment, absorb nutrients, and support fish nurseries and bird migrations. And humans love to drain them because flat, wet ground looks like a real estate opportunity. Then floods get worse downstream, and everyone acts confused. In forests, the idea of a tree line appears as you climb. Not a drawn line, but a shifting limit where conditions stop cooperating. Temperature drops, wind increases, soil thins. Trees become shorter, twisted, then vanish into shrubs and grasses. Above tree line, plants hug the ground because wind is harsh and warmth stays close to soil. It is a quiet lesson in adaptation. Life does not always fight conditions. Sometimes it simply changes shape. And forests are not static either. They migrate with climate. As temperatures warm, species move uphill or poleward when they can. When they cannot, forests thin, change composition, or burn. Fire is part of many forest systems. Some trees need heat to open cones and release seeds. Some ecosystems expect periodic burns that clear underbrush and recycle nutrients. Suppress all fires for too long, and fuel accumulates, setting the stage for hotter, more destructive fires later. Another example of human good intentions aging poorly. Wetlands and forests also store water. Releasing it slowly, they regulate local climate, reduce erosion, and moderate extremes. They are quiet infrastructure built by biology, and it works without permission. You walk along a stream in the forest, and it feels different than the river you followed earlier. The water is cooler, shaded, clear. It runs over stones covered in algae, making a soft, continuous sound that does not demand attention. This stream is part of the same erosion cycle, still carrying grains downstream. But here the process feels gentler, cushioned by roots and leaves. Even so, the landscape keeps changing, just in quieter ways. A bank collapses here, a log diverts flow there. Beavers build dams, creating ponds, trapping sediment, raising water tables. A beaver is a small animal with an impressive ability to redesign hydrology. When beaver ponds fill with sediment, they become meadows. Over time, the stream may cut a new channel. The land cycles between wet and dry, shaped by teeth and mud and time. And as the living world settles into its routines, the planet underneath keeps counting time in a different way. Patiently, endlessly, like it has been doing all along. You start noticing time in layers instead of minutes. A hillside is not just a slope. It is a stack of events, old soil horizons buried by new sediment, a landslide scar now softened by vegetation, a river terrace left high and dry when the channel cut deeper. Most landscapes you know are temporary arrangements, a coast waiting to retreat, a mountain waiting to crumble, a delta waiting to sink. The comfort is not that they are stable. The comfort is that the rules are consistent. Rocks record time in layers, like pages written slowly. Sedimentary rocks especially are diaries. Sandstone from ancient dunes, shale from quiet sea floors, limestone from warm, shallow waters filled with shells. Each layer represents an environment that lasted long enough to leave a deposit. Then it was buried. Then it hardened. Then it was lifted again, exposed to weather, waiting for you to walk past and misunderstand it as scenery. In metamorphic rocks, the story is heat and pressure. Old rocks altered into new forms without fully melting. Slate, schist, gneiss, names that sound like they belong to stern characters. They form deep in mountain roots, then later are brought to the surface by uplift and erosion. Igneous rocks tell the story of cooling melt. Basalt, granite, and everything in between. Granite cools slowly underground, making big crystals. Basalt cools quickly at the surface, making fine grains. Texture becomes a clue to where the rock was born. So when you look at a landscape, you can read it in materials. Hard rocks make cliffs. Soft rocks make valleys. Faults make straight lines, where rivers sometimes follow weakness. Glaciers carve U-shaped valleys and leave moraines, piles of debris like dumped construction material. Even without seeing a glacier, you can find its fingerprints. Striations scratched into bedrock, parallel grooves from stones dragged under ice. Erratics, boulders dropped far from their source, like the glacier forgot to clean up. Kettle lakes, small depressions left when buried ice blocks melted. And the world does not rush, which is the comfort of it. Change is constant, but it is rarely urgent. Urgent is mostly a human setting. Geology works in slow motions that do not care about your calendar. A river migrating a few feet each year. A coastline retreating after storms. A plate moving the width of your finger in a year, which is still enough to build mountains given time. Human life is brief, but it sits inside huge, steady cycles. Water evaporates, condenses, falls, flows, freezes, melts. Carbon moves from air to plant to soil to ocean to rock and back. Rock forms, breaks down, becomes sediment, becomes rock again. Even the harsh places you visited earlier, K2, deserts, volcanoes, are moments in these cycles. A mountain peak is a temporary expression of uplift winning for now. A desert is a temporary expression of moisture losing for now. A volcanic island is a temporary expression of heat escaping for now. You can lie still and imagine all of it moving at once at different speeds. Fast weather on slow rock, slow plates under fast oceans. Forests growing and burning while mountains rise and erode. And if you stay with that thought, you begin to feel how the planet holds you. Not gently, not cruelly, just mechanically. Gravity, chemistry, heat, and time doing what they do. Somewhere far away, a cliff is being undercut by waves in the dark. Somewhere inland, a river is leaning into a bend, eating the outside bank. Somewhere high, a glacier is creeping a fraction forward, carrying stones like silent passengers. And somewhere under an old quiet volcano, water is heating in fractures, waiting to rise as steam, not with urgency, just with inevitability. Above that hidden heat, the air keeps moving along its old routes, dragging moisture like luggage you did not pack. And when it finally gets tired of carrying it, it drops it, sometimes gently, sometimes all at once. You think weather is a daily mood swing. Wrong. Weather is the atmosphere doing physics on a rotating planet, and you are the small, warm object in its way. You walk along the spine of a range where storms are funneled like traffic. The wind is not random here. It is guided, pinched through passes, accelerated over saddles. One ridge can be a windbreak, and the next can be a wind amplifier. That is why mountaineers talk about a mountain having faces. It is not poetry, it is airflow. One side gets hammered, the other side gets sheltered, until the wind shifts and the shelter expires. You feel it in the snow, even when the sky looks calm. A hard crust under your boots means melt and refreeze, or wind packing grains tight. A soft layer on top can be a fresh deposit, light as flour, waiting to slide. This is how microclimates work. Not whole regions, not famous deserts, just a few meters of terrain making its own rules. A hollow collects cold air at night, because cold air sinks and stays. A south-facing slope warms faster, because sunlight hits it more directly. So you can stand in shade, shivering, and watch sunlit rock nearby steaming gently. Same altitude, same day, different atmosphere, different outcomes. Congratulations, you are living inside a system that cannot be summarized easily. The slow part is that these patterns repeat. Air rises on the same windward slopes, cools, drops rain, and keeps moving. Over decades and centuries, that repetition makes forests on one side and dryness on the other. And if you zoom out far enough, you see how entire continents get arranged. Wet tropics near the equator, where warm air rises and dumps rain regularly. Dry belts around the subtropics, where air descends, warms, and discourages clouds. This is the Hadley cell, if you want the official name. It sounds like a corporate office. It is really just the planet's habit of lifting warm air, then dropping it later as dry. That descending air is why so many famous deserts sit around 30 degrees latitude. The Sahara, the Arabian Desert, parts of Australia, dry not because they are cursed, but because the atmosphere has a circulation pattern. The sky, basically, has favorite places to wring itself out, and then the oceans complicate it, because oceans are heat storage with waves on top. Water warms and cools slower than land, so it smooths temperature swings. It also evaporates constantly, quietly loading the air with moisture. But even that moisture is not guaranteed to become rain. Air can carry water vapor and still refuse to drop it. If it never cools enough, that is why you can stand near an ocean and still feel thirsty. Some coasts live under cold currents, where upwelling brings deep, chilly water to the surface. The air above cools, and cool air does not like evaporating. So you get fog, a low gray lid, and very little rain. It looks gentle, fog rolling in like a blanket, but it is a kind of atmospheric stinginess. Plants adapt by drinking fog directly, collecting droplets on leaves and spines. You can imagine yourself as one of those droplets. You condense out of air on a cold surface, cling for a moment, then slide down. It is not dramatic, but it is enough to keep a cactus alive, which is honestly impressive. Now the storm track shifts. As it always does, low-pressure systems march across mid-latitudes, guided by the jet stream. The jet stream is a fast river of air high above, formed by temperature contrast. Warm air to the south, cold air to the north. Difference creates a pressure gradient. The planet's rotation bends the flow, and the river of wind forms. It meanders like a real river, and those bends decide who gets storms. When the jet stream dips, cold air spills southward. When it bulges, warm air moves north. And down at your level, people call it weird weather, like it is personal. Inside one of these systems, you feel the front arrive before you see it. A shift in wind direction, a change in smell, the light flattening. Warm front, cold front, boundaries where air masses meet and argue. Warm air is lazy. It would rather float than shove. So when warm air meets cold air, it rises over it. As it rises, it cools, and the moisture condenses into cloud layers. That is why some rain feels steady and endless. Stratus clouds, gray sheets, quiet persistence. No thunder, no drama. Just water arriving like a long appointment. Cold fronts are less polite. Cold air is dense. It bulldozes under warm air and forces it up fast. That fast lift builds taller clouds, deeper convection, sometimes thunderstorms. So the same ingredients, moisture, lift, cooling, make different weather depending on speed. And speed is often decided by the shape of land and the temperature of sea. You can walk through the aftermath of a storm and see the atmosphere's fingerprints. A slope streaked with fresh debris, where rain loosened soil. A river, slightly browner, carrying new sediment like a receipt. Even in places that feel stable, weather is doing slow remodeling. Rain infiltrates cracks and carries dissolved minerals downward. Freeze and thaw widens fractures, and rock becomes rubble. Now, you drift back toward the dry interior again, because the planet likes contrast. The air thins, humidity drops, and the land stops smelling like growth. You are back in the world of wide horizons and withheld water. But deserts are not only sand and sunburn. Some deserts are high and cold, where altitude steals warmth every night. The Tibetan Plateau, for example, is dry in part because it is so high. High land forces air to rise and cool, dropping moisture on edges. By the time air reaches the interior, it has spent its water, so the plateau becomes a broad, dry roof with thin air and stubborn plants. In high, cold deserts, the wind has a sharper tone. It cuts across gravel and salt and sparse grass with nothing soft to stop it. The sky feels bigger because there are fewer vertical things. You walk over ground that crunches, then suddenly does not. A thin crust, and below it, powdery salt or fine dust. This is where old lakes went to die, leaving minerals behind like bones. Salt flats form because water is a temporary visitor here. It arrives, spreads, dissolves minerals from rock, then evaporates. The dissolved load stays because it has nowhere else to go. If you stay long enough, you might see polygons in the salt crust. Cracks form as the surface dries and contracts, then refills slightly, then dries again. It is the same basic behavior as drying mud, just whiter and more deceptive. And it is deceptive because the crust can hide softness below. Some salt pans have brine under a thin layer, and vehicles sink slowly. Not a cinematic plunge, more like the ground giving up in silence. Congratulations, you discovered that flat does not mean safe. In deserts, water writes in short, violent sentences. An alluvial fan spreads at the mouth of a canyon shaped like an open hand. Flash floods rush out, lose speed, and drop their load in a wide apron. Each flood rearranges the fan's channels because the water cannot commit. It carves one path, then abandons it, then returns years later. From above, the fan looks organized, but on the ground, it is chaos history. You might also find a dry lake bed that becomes a shallow sea for a day. A rare storm fills it. Birds arrive like they were waiting nearby. Then the water disappears again, leaving a new layer of silt and salt. The desert teaches you patience in a harsh way. Most of its work happens when you are not watching. And then, occasionally, it reminds you that it still has weather. Now you go looking for green again, because humans are predictable like that, and you find it not only in forests, but in the wet seams of the world. Wetlands, floodplains, deltas, places where water slows down and lingers, and life crowds in to take advantage. A wetland feels like soft ground with hidden structure. Your foot sinks slightly, then meets resistance from roots and peat. It smells rich, like decay doing useful work. Wetlands form where drainage is poor, where groundwater is high, or where rivers spill regularly. They are not just puddles, they are systems, filters, sponges, slow reservoirs. They trap sediment the way a lint screen traps fibers, slowly, quietly. When floodwater spreads into a marsh, the speed drops. And when speed drops, sediment drops too. Fine silt settles, nutrients settle, and plants use it like a gift. That is why wetlands can improve water quality downstream. They intercept excess nitrogen and phosphorus, and microbes do chemistry on it. Not glamorous chemistry, but effective, turning dissolved compounds into gas or locking them into mud. But wetlands also make living difficult for people who want firm ground. Mosquitoes, soft soil, seasonal flooding, nature's way of discouraging permanent architecture. So humans drain them, straighten channels, and act surprised when floods get worse. Forests, too, are not just scenery. They are climate machines at local scale. They shade the ground, reduce evaporation from soil, and release moisture through leaves. Transpiration is the polite word. Trees sweating for the community. That moisture can become clouds, and those clouds can become rain. So forests can help maintain their own humidity, a feedback loop. Cut enough trees and the local air can dry out, reducing rainfall. It is not instant and it is not always simple, but the point is steady. Vegetation changes atmosphere, and atmosphere changes vegetation. A landscape is not just shaped by rock and water, but by biology doing persistence. And the ground under that biology is never inert. Soil is built from broken rock and decayed life, mixed by roots and worms. It holds water like a sponge and nutrients like a pantry. The texture matters. Sand drains quickly, holds little water. Clay holds water well, but can become sticky and airless. Loam, the balanced mix, is the kind gardeners brag about like they earned it. Soils also form in layers called horizons, a darker top layer rich in organic matter, then lighter mineral layers below. In old, stable landscapes, these horizons can be thick and well developed. In new landscapes, like fresh volcanic deposits, soil is thin and young. It begins with microbes and lichens, then small plants, then larger ones. A slow succession, life arriving in stages like a cautious crowd. But even mature soil can vanish quickly when the surface is disturbed. Remove vegetation, and rain hits bare ground harder. Water runs off faster, carrying fine particles away. That fine topsoil is the valuable part, the part that took time. Lose it, and the land becomes less productive, more prone to erosion. And then you get dust in the air, rivers clogged with sediment, reservoirs filling early. Everything connects back because the planet enjoys loops. You walk up to the edge of another tree line where forest thins again. The trees become shorter, bent by wind, shaped like they are leaning away from something. They are away from exposure, away from cold, away from dehydration. Wind can dry plants out even in cold places. When the ground is frozen, roots cannot pull water easily. So needles and leaves lose moisture to wind, and the plant cannot replace it. That is why treeline is not just about temperature. It is about wind, soil, snow cover, and the length of a growing season. A boundary drawn by multiple quiet stresses, not one dramatic cause. Above treeline, alpine meadows appear in summer, brief and determined. Small flowers, low grasses, insects taking advantage of a short, warm window. Then winter returns and the whole thing goes dormant again. You start noticing how many landscapes live on schedules you do not share. Plants timing growth to snowmelt, rivers timing floods to monsoon, animals timing migrations to blooms. And underneath those schedules is the deeper one geology's time. Uplift and erosion, sea level rise and fall, glacial advance and retreat. The big slow metronome that keeps ticking whether anyone listens. You can feel that time most clearly when you stand somewhere that looks ancient. A shield of exposed bedrock scraped clean by old ice. A boulder sitting alone, dropped by a glacier that melted 10,000 years ago. Glacial landscapes have a specific bluntness to them. U-shaped valleys, wide and steep-sided, carved by ice thickness. Hanging valleys, where a smaller glacier joined a main one, left stranded above. When ice retreats, it leaves moraines, piles of unsorted debris dumped at edges. Not neat river gravel, but a messy mix of clay, sand, cobbles, and boulders. Till, the technical word, meaning the glacier did not bother sorting anything. And then meltwater takes over and starts sorting, building outwash plains. Braided streams spread across gravel, shifting constantly. The landscape looks unfinished because, in a way, it is. In places that were once under ice sheets, the land is still adjusting. Isostatic rebound lifts old shorelines, changing drainage patterns. Rivers get rerouted, lakes tilt, wetlands form where water collects. So even the end of an ice age is not an end. It is the start of a long, slow correction. And now, as you keep walking through these connected systems, you start seeing human life as another layer, not separate from geography, just laid on top of it like a temporary tarp. Roads following ridgelines, cities clustering at river mouths, farms spread across floodplains. Humans build where the land makes it easy, and then complain when the land behaves like itself. Coasts erode, so we armor them with walls. Rivers flood, so we constrain them with levees. Dry regions thirst, so we pump aquifers that took millennia to fill. Sometimes it works for a while, and then maintenance costs pile up, and the planet keeps applying pressure. Not maliciously, just consistently, like gravity refusing to negotiate. Even places that seem safe are only safe on certain timescales. A river valley might stay calm for decades, then flood beyond memory. A hillside might look stable, then slip after one saturated season. A fault might stay quiet for centuries, then release in a minute. And this is where deep time becomes oddly comforting. Not because it is kind, but because it is honest. The planet does not promise stability. It only promises process. You can hold that thought without forcing it into a moral. Just the simple idea that landscapes are verbs, not nouns. A coastline is waving, a mountain is rising and falling. A desert is exporting dust. Even rock that looks permanent is only paused, waiting for new conditions. Add water, it dissolves or breaks. Add heat, it metamorphoses or melts. Add pressure, it folds, faults, and changes shape. So the Earth is not built once. It is rebuilt continuously with the same few tools: heat, gravity, fluids, and time. And you, tonight, are just tracing the routes those tools take. You pass one more place where the ground underfoot tells an old story. Layered stone, tilted slightly, like pages pushed sideways. Each layer once lay flat, deposited in water or wind. Now they are angled because the crust was squeezed and the layers bent. That tilting is a quiet signature of tectonics preserved in stone posture. Rock that learned to bow under pressure and never fully straightened again. If you follow those tilted layers downslope, you might find a spring. Water emerging where a permeable layer meets an impermeable one. The geology decides where water can travel and where it must surface. Springs are the land admitting it has plumbing. They can feed streams even in dry seasons, keeping valleys green. They can also vanish if groundwater drops because humans drilled too many wells nearby. Even that feels like the same theme repeating. Water moves where rock allows it, and life gathers where water lingers. And humans arrive after, building routines around those gathering points. You keep moving through this stitched-together world, and the scale keeps shifting. A single droplet in a soil pore, then an entire river basin. A dune, grain hopping, then a continent drifting. It is all the same set of motions, just at different speeds. Fast air, slow rock, fast storms, slow mountains. And under everything, the mantle turning over like a patient engine. For now, you let that engine stay out of sight. You stay with the surface, its textures, its quiet rearrangements, and you follow one last thread of change, the kind that does not announce itself loudly. Because even in places that look settled, forests, wetlands, gentle hills, the ground is still traveling. Soil creeps downhill, millimeter by millimeter, pushed by rain impact and freeze thaw. A slow-motion landslide that never makes the news. Rocks break, roots pry, microbes dissolve minerals, and every year another thin layer moves. The hillside becomes slightly lower. The valley becomes slightly fuller. It is the planet smoothing itself, slowly, like hands over wrinkled fabric. And as that smoothing continues, you start to notice how often the Earth reuses its own material. Sandstone becomes sand again. Mountains become deltas. Deltas become seabed. Seabed becomes mountain. It is not a circle you can watch in a lifetime. It is a circle you can only imagine, which is sometimes the only way to grasp it. So you keep imagining, following the grain, following the slow push. And when your mind reaches for an end, the planet refuses to provide one. It offers only the next process, the next rearrangement, the next quiet turn in the cycle. Somewhere out beyond the